last time we met, we talked about holes and vertical asymptotes. So let me remind you what those are. If I have a graph that approaches a line but never touches, that's called an asymptote. Now, there are such things as horizontal asymptotes. There are also vertical asymptotes. So you might have a graph that looks like this. So this vertical asymptote might be at x equals 3, and this horizontal asymptote might be at y equals 2. Okay? So we're working on page 90, and we're breaking it into 3 different days. All you had to do last time was find the domain. And when you have a rational function is just a polynomial divided by another polynomial. So like x to the third over something x to the fourth. Okay? And they all have graphs that follow the same sort of qualities. Okay? So in this case, the domain would be all real numbers, and it's always all real numbers. If it's a polynomial divided polynomial, it's always all real numbers. But in this case, x cannot equal whatever the value of the vertical asymptote is. And the vertical asymptote is 3, so we have x cannot equal 3. But we also learned about another structure. We called it a hole. So you might have a graph that comes up and it's got a gap. Let's say at -2. So x cannot equal -2. So we called this one a vertical asymptote, and this one we called a hole. And we also know how to find those from the equation. So if the graph has a hole, what do I know about the equation? The factors canceled. So whatever this equation is, it has an x plus 2 in the bottom. Okay? And it also has an x plus 2 in the top. And what else does it have in the bottom? An x minus 3. So, and then it could have more things on top. We don't know. It could also have like a 6 in the bottom, some number. But we know there are no more x's in the denominator. It has one hole and one vertical asymptote, so the denominator is an x squared. The top could be lots of things. It could be an x to the 5th. We're not sure. So the function could be x plus 2 over x squared minus x minus 6. And I want to show you something. If I plug in the value of the hole, watch what happens. If I plug in -2, I get 0 over 0. That's what creates a hole, 0 over 0. If I plug in the vertical asymptote, I get 5 over 0. So whenever you have 0 over 0, that's where the graph just totally freaks out and it doesn't have an answer. When you have some other number divided by 0, that's a vertical asymptote. Okay? So your assignment last time we met was to go through all the problems on 90, factor the bottom, factor the top, state the domain, which is all real numbers except when the denominator is 0. If the factors cancel, then it's a hole. If they don't cancel, then it's a vertical asymptote. All right? There are 2 other types of asymptotes. We'll talk about those today. So over here, we need to factor the top and factor the bottom. Does the top factor? Pull out a 2, and I get x plus 3. Does the bottom factor? X minus 8 and x plus 3. So those cancel. So my domain is all real numbers, but x cannot be -3 or 8. Does that make sense, Caitlin? So I factored the bottom. If I plug in 8, I get a 0 there, which makes this whole thing 0. If you divide by 0, that's infinity, which can't exist. So anytime the denominator is 0, that value is not part of the domain. So whatever this graph looks like, -3 is not part of it. Also, 8 is not part of it. If the factors canceled, that creates what we call a hole. If the factor does not cancel, that creates what we call a vertical asymptote. So that's what you need to do on 90. Go through all the problems, find out where the domain does not exist, and state whether it's a hole or a vertical asymptote. Okay? All right. Turn to page 84 in your book. And this is an explanation of all the types of asymptotes. So an asymptote is a line that a graph approaches as x increases or decreases but does not intersect. Horizontal and oblique asymptotes occur with rational functions and model end behavior. So the first one, you see the line y equals -3 is a horizontal asymptote. Now, a function can only have one horizontal asymptote. Well, a rational function can only have one horizontal asymptote. It'll never have two. It'll always have one or none. And then we have what is called an oblique asymptote. An oblique asymptote is an asymptote that follows a linear pattern that's not horizontal. So it could be a positive or a negative. And if it has a horizontal, it cannot have an oblique. If it has an oblique, it cannot have a horizontal. So usually it has one or the other. There are some cases, which we're not going to run into, I don't think, where it has none. But it could be one or the other. And then the last one says vertical asymptote. A graph can have as many vertical asymptotes as there are factors in the denominator. So if I had like x squared something 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 over x to the 5th, it could have 5 vertical asymptotes. It might also have, how many holes could it have? It could only have 2, because there are only 2 factors on top. So the highest number of factors that could cancel would be 2. So it might have 5 vertical asymptotes, it might have 1 hole and 4 vertical asymptotes. It depends. Okay. It might also have none, because this might have complex roots. Well, that's not true. It's got at least 1, but we're not going to get into that. Okay, so how do you tell? It's actually really easy. You just need to memorize this chart that we're going to show you. So turn the page. Okay, so we have this function up here, f, and this is a really fancy way to say a polynomial divided by another polynomial. So don't let this equation mess with your head, because it's really simple. It says we have some polynomial p divided by some polynomial q. And then it says p is a times x to something, and then you can see it just gets lower and lower. So like 5x to the 5th minus 4x to the, third plus 2x to the 1st, whatever. So the top is a polynomial and the bottom is a polynomial. Okay. So we know how to do number 1 and we know how to do number 2. Number 3, the graph of the function f has at most 1 horizontal asymptote. Okay? Does anybody remember what the word degree means when talking about polynomials? If I had 4x to the 5th minus 7x squared, what is the degree? This is the degree. The degree is the largest exponent. All right? What do we call this number? Coefficient. In fact, it's the leading coefficient, because it's the one in front of the largest exponent. Okay? So in the top function up here, the leading coefficient is a, and then the bottom, the leading coefficient is b. That'll be important. So 3 bullet 1. If the degree of the top function is smaller than the degree of the bottom function, then the horizontal asymptote is at y equals 0. So if the polynomial on bottom is bigger than the polynomial on top, meaning the exponents, then y equals 0 is the HA, the horizontal asymptote. That's easy. The bottom is bigger than the top, then it's automatically 0. Okay? The second bullet says, if the degree of the top function is equal to the degree of the bottom, then you divide the leading coefficients, and that is your horizontal asymptote. So if I had x plus 1 over x squared minus 5, the bottom is bigger. The bottom is a quadratic, and the top is linear. So I have an HA where y equals 0. All right? But what if I change it to, say, 4x squared over x squared? Now I divide the coefficients. Yeah, the top and the bottom have the same exponent. So I divide the coefficients and I get 4. So the HA would change to y equals 4. It's really easy. Yeah. So, yes. Yes. Because the rest of it doesn't matter. The rest of it will change how fast it approaches that asymptote. But in the end, it's never going to get there anyway. So, and that's a really good question. All of this stuff that happens over here, that's just going to change. So if that's my asymptote, one of them might get close really fast, and one of them might get close really slowly. But in the end, none of them are going to get there. So we can ignore all of this information, and we just focus on that. Okay? Okay, and then the last one is where it gets a little bit tricky, but it's still not hard. If the degree of the top is bigger than the degree of the bottom, then there might be an oblique asymptote. And they don't tell you this, which they should. The only time you get an oblique asymptote is when the top is one number bigger than the bottom. So if the top is an x to the 5th and the bottom is an x to the 4th, then you get an oblique, because the difference between them is linear. Does that make sense? So if I had like 5x to the 5th over 7x to the 4th, the difference between these is 1x. And x is a linear graph. If I change that 4 to a 3, now the difference between them is a quadratic, so we cannot have a straight line asymptote. And I believe on your assignment today, they all differ by 1. I'll show you. If it does, I'll show you. You should automatically know. If you don't, and you spend all the time to work out the problem, in the end you'll realize, oh, that was a waste of time. Okay? So, what you do is you long divide them. If the top is bigger than the bottom, then you do long division, and the equation you get as your answer is the equation of the oblique asymptote. And it might have a remainder, and the remainder doesn't matter. Yes? No, the whole polynomial. Okay, so let's, we'll look at their examples. So turn to 86. And they've got it all worked out for us, so we can just look at it. So we have this function here. Which is bigger, top or bottom? Bottom. If the bottom's bigger, what does that tell us? The HA is at 0. Now, they factored it for us, and just for practice, does this have VAs or holes? They're both VAs. Where are they? 3 and -2. Neither of them canceled, so they can't be holes. And then the HA is going to be 0, because the bottom is bigger than the top. Okay, look at the next problem. So, which is bigger, top or bottom? They're the same, so we divide the leading coefficients and we get an HA at 2 over 1. All right? And they factored it for us over here. That's one of the answers. Um, does this have any holes? No, none of the factors cancel. Does it have any vertical asymptotes? Where? 2 and negative 2. Okay? All right. Okay. So now which is bigger, the top or the bottom? Top is bigger, so it probably has an oblique asymptote. Do they differ by one number? Yes, the top is an x squared and the bottom is an x. So what we do is we ask how many times does x plus 2 go into x squared minus 2x plus 3? Okay. So how many times does x go into x squared? X times x is x squared. X times 2 is 2x. Now what do I do? Draw the line, change the signs. First one cancels. Negative 4x plus 3. How many times does x go into negative 4x? Negative 4. So now I multiply negative 4 and x is negative 4x. Negative 4 and 2 is negative 8. Draw the line and change the signs. That's going to cancel, and I have a remainder of 11. Sorry. Well, that remainder is going to affect how fast the line approaches the oblique asymptote, but it's not going to change the end behavior. So we just throw out, we don't even care what this number is. If it's 0, great. If it's not, whatever. We don't care. The equation of the OA is x minus 4. So the question was asked, how do I know in the end if it has one? If your answer is anything bigger than linear, then it doesn't have an oblique asymptote. So if you do all this and you get x squared minus 2x plus 1, then you know it has no oblique asymptotes, which you should have picked up because these two should differ by 1. So it has an OA when y equals x minus 4. So if I were to graph this, something like that, and something funny happens sometimes. Every once in a while, a line will pass through the oblique asymptote. Sometimes it does, sometimes it doesn't. So we might have a horizontal here, and it might go something like this, or a vertical, sorry. And then the other one might look like this. Sometimes it will go through near the origin, and that just happens. We'll talk about that tomorrow a little bit more. Okay. All right. So look at your assignment on page 1. Does it have an HA or an OA? We're not doing range yet. No. I haven't taught you. We're going to do it in a second, but we haven't done it yet. So it has an HA where? Well, is the bottom bigger or are they the same? The bottom is bigger, so the HA is automatically at 0. Yes. The HA is y equals 0, right? Okay. Well, how does that affect the range? Well, if we have a horizontal asymptote at 0, what values do not exist? 0, right? Y can never be 0. Okay. Number 2, bottom bigger or top bigger? What's that? Right. All real numbers except 0. Yep. The range is everything but the horizontal asymptote. unless it's an OA, and that's a little more complicated, but we'll get there. Okay? All right. So number 2, where is the HA? 0 again. All right, let's skip to number 8. Does number 8 have an HA or an OA? An HA. How come? They're equal. It's x to the first and x to the first. So what is my HA on number 8? 3/5. So the range would be, all real numbers but 3/5. Well, let's not do that today. Skip the range today. It's more complicated than that. So don't do the range, just do the HAs today. All right? I haven't lied to you yet, but it does get more complicated. Okay, so look at number 18. Does 18 have an HA or an OA? It's an OA. How do I know it's an OA? The top is bigger, and more specifically, it's 1 bigger. Right? If the top is 2 degrees bigger than the bottom, then it doesn't have an oblique asymptote. It has something else. So we write, it does have an OA, and then we need to find it. So we do long division. X plus 1 goes into 3x squared minus x. I'm missing a 0, so I need to put a plus 0. Am I going to end up using that? Not in this case, because we don't care what the remainder is. But if you're missing an x term, if it was like x squared minus 16, you need that 0x term. But because we don't care about the remainder today, we can just throw out that 0 at the end. So how many times does x go into 3x squared? 3x. So 3x times x is 3x squared. 3x times 1 is 3x. Draw the line and change the signs. First two cancel, and I get negative 4x plus 0. How many times does x go into negative 4x? Negative 4, and I can stop there, because I don't care what the remainder is. All I wanted to know was 3x minus 4. Is that a linear equation? Yeah, so we're good. So the OA happens when y equals 3x minus 4. So go back through this assignment and find either the HAs or the OAs for all of the problems. Make sure you leave room to graph it. We'll learn what we need to do tomorrow to graph it, and we'll finish this up. Okay? Need some help?